In order to solve part 1, you must know that in this park, there's an area of 225 kilometers square. And in every 1 km square can support the habitats of at most 4 bears every year. And since n is the maximum number of bears that the park can support every year, the value of n is simply 225 times 4. For parts 2, you are given that 3% of the bear population is killed every year. You are to modify the given differential equation to include this information. The modification will then be just to take away 3% of y, where y is the number of bears in time t years. The second part of part 2 says that you are supposed to use this substitution to show that the differential equation can be written as the one highlighted in green. Let us look at the solution. To do your substitution, you will first have to differentiate. You will obtain du dt equals to 1 over y dy dt. After which, you are then supposed to substitute this into the given differential equation, the modified one. And since dy dt equals to y times of du dt, when we substitute dy dt, we will obtain y du dt. And we know that u is simply equals to ln of y over 900. That is how we obtain u over here. Some manipulation will get you to the final answer. Part 3. What is a long-term stable population? When we talk about the long-term stable population, there are 2 terms that you pay close attention to. One, when we talk about long-term, we are talking about time going towards infinity. And when we talk about stable, we are considering a population that is going towards a limit. Hence, in order to find the long-term stable population, we must first solve the differential equation. Solving the differential equation will then give you an equation that looks like this. We must then consider long term. That is, the time going to infinity. And you notice if time goes towards infinity, you will realize that the term e to the power minus 1 over 9t goes towards 0. That being the case, e to the power of b e to the power minus 1 over 9t minus 27 over 100 will actually tend to e to the power of minus 27 over 100. Hence, y will then tend to 900 times of e to the power of minus 27 over 100. That is how you find a long-term stable population. As for the last part, you are supposed to state one assumption about the model. Possible answers will be You have to assume no migration of bears in and out of the park. Bears are not infected by virus. Bears are evenly distributed in the park.